Good morning, everyone. Today we are going to discuss about uh, unique ambiguity in the mathematics while we solve about the volume and the surface area of geometrical figures. Just suppose that we are talking about a cube. It will have a definite volume as well as a surface area, which is definite. So there is not like if we are going to paint this thing or fill up this whole cube, we just don't need like an infinite amount of paint or infinite amount of color. Normally, what we think that everything that is around us, like a chair, uh, a book, everything has a fixed volume as well as a fixed surface area. But here comes the Gabriel Horn paradox, which is quite like that is a geometrical figure according to which it has a fixed volume, but it doesn't have a fixed surface area. Fixed surface area, which means it doesn't have a finite surface area. If I am going to paint its outer surface, I don't have enough paint to paint it out. And when I'm going to in fill in some kind of liquid inside it, there would be a finite amount of liquid that I can fill it, which is equal to pi. It has a volume of pi, but surface area infinity. So let us discuss about it. So let's see. This is a 3D model that I have created. So you definitely know about graph of 1 y equals to 1 by x. It looked like this. I think so. You would know about it, है and what is it? I'm going to take a very small part of it, which is x greater than equals to 1, and which is shown in this 3D diagram. Okay. This is the thing that I have taken, graph that I have taken. Uh, and the starting point is uh, x equals to 1 and y equals to 1. So what I'm going to do is rotate this graph around the x-axis. So to make a 3D figure. And how this 3D figure will look like? It will look like this. It is 1 meter high, and it is 1 meter away from origin. It will look like this. If we look in complete 3D model, it will look like this. So let's discuss about what is the main problem um, around it regarding finding surface area and the volume of um, this geometrical object, or what would you say, geometrical figure. So let's discuss about how we are going to find its volume, which is finite. So let us find it first. Okay. So how do you find a volume of this figure? Like I have a function of y equals to 1 by x. So let us take an element. It is a disk of radius r, and r equals to 1 by x, of course. And what I'm going to do is taking an element of dx thickness, because so this is a disk, this is the thickness. So how do I going to write its area? It's small areas. That this is a small disk, and I am going to write the small area for this small disk. And I'm going to write I'm going to write it as I1 by x square. And what would be its volume? Volume would be area into the thickness, and it would be this. Okay. So from where to where I'm going to integrate it? I'm going to integrate it from 1 to very infinity. 1 to n. So the integral would be 1 by x negative 1 to infinity minus pi minus pi 1 by infinity minus. So volume is pi unit. And now let's find surface area. What will be its surface area? What will be its surface area? What will be its surface area? Let's take a ring of thickness r. It would be 1 by x, and ring of the radius r and thickness x. Okay. So the surface area would be 2 pi 1 by x into x. And integration would be same from 1 to infinity. And now you would see it is going to be it is going to approach to infinity. So, why it really happens? So, why it really happens? The reason is quite simple.